Hello, fourth grade, and welcome to 5.5, Use partial quotients to divide. So I've talked a little bit about partial quotients in the past, and now we'll talk about it a little more explicitly. Partial quotients just means that it is part of your quotient. It's not your complete quotient. Think about partial products. And so in this lesson, we're going to divide by thinking about multiplication, estimation, properties, and place value. And this is why we had to go part by part, first through addition, subtraction, multiplication, and now division. Let's go ahead and begin with our solve and share on page 185. And our math tip for this lesson is you can think about how many times you take away from groups of 6 from your original number.
Sally's bird feeder holds 6 cups of bird feed. How many times can Sally's bird feeder be filled using a 72-cup bag of bird feed? Use counters or draw pictures to solve this problem. Explain how you found your answer.
So since we're trying to figure out how many groups of 6 can fit into 72, we can go ahead and try to figure out what quotient, what number we can use to multiply 6 times what gets to a number close to 72. So let's go ahead and see what happens when we do 6 times 10. When we do 6 times 10, we can go ahead and start from 72. And we said 72 divided by 6. We said 6 times 10. And so that will give you 60. And so now let's go ahead and find the difference. And you should get 12. But since there's still some amount left over, we can go ahead and multiply by 2 now. We're still talking about the 6, by the way. And so now we can go ahead and remove that 12. And now there are no parts left over. There are no remainders. So now I'm going to combine these two partial quotients because I had 10 groups of 6 and 2 more groups of 6. So now I have 12 groups of 6, and that is our whole quotient. These were our partial quotient. Let's go ahead and begin on page 186. So we're on page 186. If you have completed using the glossary to help you find that definition for partial quotients, then you're ready to go.
How can you use partial quotients to solve division problems? There are 3 seats in each row of an airplane for passengers. If there are 63 people boarding the airplane, how many rows of seats are needed for the passengers? This bar diagram shows the problem, where R equals the number of rows. Which operation can you use to solve the problem? How many groups of 3 counters can be taken away from 63? You can divide by finding partial quotients until only a remainder, if any, is left. How many 3s are in 63? Try 10. 10 groups of 3 is 30. 63 minus 30
Select
equals
your answer.
33. How many 3s are in 33? Try 10. 10 groups of 3 is 30. 33 minus 30 equals 3. How many 3s are in 3? 1. 1 group of 3 is 3. 3 minus 3 equals 0. 10 10 and 1 are partial quotients. There are 21 groups of 3 in 63. Sometimes you can use a different first estimate.
Drag the slider to explore the steps in using partial quotients to divide.
There are 21 groups of 3 in 63. 21 rows of seats are needed.
How can you use the relationship between multiplication and division to check your answer?
So when we think about multiplication and division, when we're multiplying, what we're doing is the opposite of dividing. And so when we divide, we're also doing the opposite of multiplying. So if, for example, we multiplied by 21, we could check 3 times 21 to see if we actually get 63. And if it showed that it was 63, then our division is correct. So 3 times 1 is 3. 3 times 2, that's going to give us 6. So we know that 63 divided by 21 equals 3. Or we could say 63 divided by 3 equals 21. And so that's how multiplication and division are connected to each other. That means if I have 63 rows or 63 items and I divide them into 21 groups, I'll have 3 in each group. Or if I have 63 items and I divide them into 3 groups, I'll get 21 in each group. Let's go ahead and begin our guided practice. And so here's another way that we could solve by, of course, breaking it apart into place value using the distributive property. So for 5.5, you're using partial quotients to divide. A partial quotient is a way to divide that finds quotients in parts until only a remainder, if any, is left. For example, here we have 2 divided by, or 22 divided by 2. And so you'll notice that I have a 10 here and I have a 1 on top of it because I'm going to combine both of them. And these are our partial quotients. Then when we combine it all, that is our actual quotient. So 2 divided by 22 equals 11 because 10 plus 1 makes 11. So I can divide by thinking about multiplication, estimation, properties, and place value. Partial quotients are helpful for getting near the quotient and piecing together what the total quotient is. For example, 63 divided by 3. Or, if you want to write it this way, I know at least 10 groups of 3, 10 times 3, are in 63. I can put it as part of my quotient. So here, 3, and then I have the 10 because that's what I'm saying, 3 times 10, and I get 30. When I subtract, my goal is to remove until nothing is left, or the remainder is too small. But here, when I subtracted my 30, I had 33 left. Since there are 33 left, I can remove 11 groups of 3, or 11 times 3, to remove the rest, because I have 33. So now I put my 11 right there. These are my 2 partial quotients. And then when I combined my 11, because now when I subtracted my 33, that's 0, my 11 plus my 10 gave me 21. So my actual quotient is 21. I can also choose a larger number to multiply by to find the quotient. For example, again, 3 divided by 63. And here, I'm starting with 60 divided by 3. Well, I know that's going to be 20. So I can go ahead and start from 20. And so I have 20 here. 20 times 3, that gives me 60. And then I have 3 on the bottom. Since there are 3 left, so there were 3 left, so 21 groups of 3 in 63 because 3 can go into 3 one time. So these are my two partial quotients. And so now I remove that last 3 and I have 0, no remainders. So I have 21 groups of 3 in 63. I can also break apart a number into place values to divide them. So here's another example, 69 divided by 3. Here we have 60 plus 9, and again divided by 3, adding them up afterwards. 60 divided by 3 and 9 plus 9 divided by 3. So I have 20 plus 3. And now I have 69 divided by 3 equals 23. For our guided practice, it says Harry used the model below to find 84 divided by 4. Use the distributive property to show why Harry's strategy works. So here, when we look at 84 divided by 4, we know that these are groups of 20. And so 20 plus 20 is 40, plus another 20 is 60, plus another 20 is 80, and then there's 4 more. And so we know that these are 4 groups of 20, and then another group that just has 1 right here. So looking here, we can see that there are 4 groups, and that's how we're dividing it into 4 groups. And so now there's 21 in each group. And so it says here, use the distributive property. So let's go ahead and show the distribution. So 84 divided by 4, the way that we're saying it is 84 divided by 4 is equal to 80 plus 4 divided by 4, which is equal to 80 divided by 4 plus 4 divided by 4, and that's why there's a group of 1 there. So 80 divided by 4, 4 times what equals 80? Well, 4 times 4 equals 32, but let's just think about 4 times what equals 8. 4 times 2 equals 8, so in this case, 4 times 20 equals 80. And then 4 divided by 4 equals 1, so now I have 21 as my actual quotient. And that's what we have here, 20 and 1 for each group. They are equally divided. So there are no remainders here. For number 2 to 3, use partial quotients to divide. Use counters or draw pictures as needed. So how many groups of 4 are in 48? So looking at 4 and 48, I know that there's going to be at least 4 groups of 4 in here, because 4 times 4 will give me, 4 times 1 will give me 4. So there's at least 1 group of 4 in there. And so I can go ahead and put my 40 here. So that's at 10. And I subtract it, and I'll have 8 left over. And then 4 times 2 will give me 8. So now 4 times 2, put an 8 right there, and I know that it's going to be a 0. So now I can combine my partial quotients, and I get 12. So there's actually 12 groups of 4 in 48. For number 3, how many groups of 6 are there in 78? Again, 6 can go into 70 at least 10 times. And so now I get 60 on the bottom. And now I'll have 18. 6 can go into 18 3 times. And I know that's going to give me a 0 at the end. So now, when I combine my partial quotients, I'm going to get 13. So there are 13 groups of 6 in 78. And you'll be doing the same idea, or you're practicing the same idea for the rest of your independent practice. And so if you're stuck on any of the questions, go ahead and leave a comment in the classroom. Otherwise, go ahead and try it out, do your best, and make sure your work is neat. That is the end of this lesson, and I'll see you in our next one.